Now, we had looked in previous videos at stationary points in partial derivatives. One was a maximum point and one a minimum point. Now, we're going to look at what is called a saddle point. Alright? As to the reason why I call it a saddle. This somewhat looks like the saddle that you put on a horse before you climb up and ride the horse, right? So we call this a saddle point. Now, at this point is where you have the curve meet. It's not a maximum point and it's not a minimum point either. Even though the tangent along the x has a gradient of 0 and the tangent along the y also has a gradient of 0. Alright? Well, let me interchange that. The tangent along the y, the blue, the change in y is f of y. The tangent along the y has a gradient of 0 and the tangent along the x function also has a gradient of 0. So in both cases, delta f by delta x is equal to 0 and delta f by delta y is also equal to 0. So you can find the location of the stationary point just as you did previously when there was a maximum and minimum. So what you do is solve both delta f by delta x equals 0 and delta f by delta y equals 0. Simultaneously. You have a pair of simultaneous equations to solve. But then, let us see what happens with the second derivatives. From looking at it, you can see that you have a delta squared f by delta x squared. In this case, it will be greater than 0 or positive. When you look at the y, delta squared f by delta y squared is less than 0. So it is negative. Now the fact that you have a positive here means a minimum point for x. And the fact that you have a negative here, it means a maximum point for y, right? And you can see it here. Along the y function, you have a maximum point, you go up and then down. Along the x function, you have a minimum point, so you go down and then up. Now, when one of them is positive and the other is negative, this is what you have. It's a saddle point, all right? Now, if you have the x being positive and the y being negative, you would also have a saddle point, all right? So that would also be the case. Can I draw this saddle point? Let me see something here. What would this be shaped like? Try my hand at drawing this. All right. So you have this case, and then on the x here, the x value, see if I can draw it like this. Just trying my hand at drawing the saddle point, right? I guess you'd have to turn it this way. So you'll be sitting on a saddle. That's somewhat like this. I think you'd have to turn this around, right? You have to turn the saddle around. Whichever way you're sitting here, you'd have a similar saddle where you sit in the other direction, alright? Alright, so that is what we have in this case, alright? But I can only spin this upside down, but probably this is the situation that you'd have. So over here you have the blue, Y goes up then down. Here Y goes down then up. So Y has a maximum here, Y has a minimum here. Alright. Over here X is a minimum, over here X is a maximum. So I guess that is the situation that you would have here. Alright. For this saddle point. See if I can turn it to be more balanced. Probably it would look something like this, right? So in this case you have one second derivative, or one of the second partial derivative positive and the other second partial derivative negative. You have a saddle point.